What up, what up, what up? It's the Jets with the mess and all science. Good.
In today's lesson, students will be able to understand conservation of momentum, momentum conserved in collisions, how to solve for conserved momentum, momentum conserved in objects pushing away from each other, and why momentum matters.
Today we will be diving into conservation of momentum. What is conservation and what is momentum? So we all have an idea of what the word conserve means. I think about saving, stopping it from being destroyed. With that being said, conservation is the principle by which the total value of a physical quantity or parameters such as energy, mass, linear or angular momentum. Now, anyone who's been active in any kind of sport can grasp the idea of what momentum is. Think about energy. Momentum is a vector quantity defined as the product of mass and the velocity of an object. So any object basically has momentum. So critically thinking with knowing what both conservation and momentum is, the conservation of momentum is a fundamental law of physics which states that the momentum of a system is constant if there are no external forces acting on the system. Here's an example of conservation of momentum.
Another example of conservation of momentum occurs when two or more interacting objects that initially have no momentum occur being moved. For example, you are standing in a resting position and then you jump, leaving the ground with a velocity. Obviously, your momentum is not conserved. Before the jump, it was zero, and your mass and your velocity combined as you began to rise. However, the total momentum remains constant if you include Earth's gravitational pull. Another example would be two objects moving in opposite directions. Imagine two skaters pushing from each other. Both skaters are initially at rest, so their momentum is equal to zero. When they push away from each other, they move in opposite directions with equal but opposite momentum. So the total final momentum is equal to zero.
What happened in your example? We found that ball A on the left did not remain constant. And we also find that ball B does not remain constant, but the total momentum of each ball and both balls combined does remain constant. See, in general, the total momentum remains constant for a system of objects that interact with one another. So in this case, the billiard balls are the only two objects interacting. If we had a third object exerted a force on each one of the balls, the ball A or ball B will not remain constant, but the third object will remain constant.
I know you've all heard the saying that everything happens for a reason. In every class, there's always that one classmate that's like, why do we need this subject? What is it going to do to help us in our life? Why do I need that? How is this going to...
Asking all them questions. Why you asking all them questions? Making statements.
Here's why conservation of momentum matters.
It's an issue. Oh, man.
The key to many safety features is the concept of impulse, a change in momentum on an object. Inventors of the car have used that concept of impulse to create sheet metal and a frame structure to absorb energy before reaching the passenger. This then slows the car and keeps the drivers alive and not instantly dead. So yes, momentum can help us survive car accidents and head-on collisions all the time. Seatbelts and airbags also is aided by momentum. Momentum helps seatbelts stretch and extend our bodies, while airbags extend time of momentum, which reduces force and keeps us alive. So science does say, stay strapped and buckled up.
And that's all I have for you. I'm gonna move on to the next part.